Alright guys, so I am back today with another video. I know you're so pumped. I'm just going to show you how to find the lateral area, surface area, and volume of a pyramid and a cone. So I'll start with the pyramid, I'll end with the cone. So anytime you have a solid figure that comes to a point, that's a pyramid, and then based on what the base is, well, about that base, am I right? That's how you name the pyramid. So this would be a rectangular pyramid because the base is a rectangle. Well, actually, in this case, our base is a square. So I don't know if it would be called a square, like square-gonal pyramid. I have no idea, actually. I should have looked that up before I started this video. But let me give you the values that we have here. So 10, and the units are inches. And then, so from the center of the square to the top, I can make that clear, that's 12, oh, I hate that, I just did that, inches, and then from the middle to the edge here is 5 inches. Okay, so it's like you just kind of drop this like plumb line from the top of the pyramid to the center. So that's the height of the pyramid, that's 12 inches. And then from that center to the side is 5 inches. So this, of course, is a right triangle. Okay, so because this pyramid has all like polygonal shapes on that make up the sides, that was a really terrible sentence. We can just find the surface area with the same method that I was using for the prisms, which is just figure out like what shapes you're working with, find the area of those shapes and add them together. So we've got a square, obviously that's 10 times 10, so that's 100. That was easy. And then we've got these 4 triangles. Oh, good grief, I am losing my touch. Okay, 4 triangles. So I need to find the area of the triangle. So if I just draw the side, okay, this triangle's better. Oh, look at that. That's like perfect. If I want to find the area of this triangle, my phone's ringing. I'm just going to ignore it for right now. The base is 10, and I need the height. Okay, well, here's the thing. I didn't give you the lengths. Like, I didn't give you these lengths here, right? So, you're like, oh, how do I find the height of that triangle? But here's the thing. We do have this triangle here. And I'm hoping that you'll be able to see this. So this is kind of like, if I cut the pyramid in half, like if I sliced it, this triangle appears, right? So this dotted line is the height of this triangle, but it's the hypotenuse of this triangle that we do have the values of. So like if I draw this triangle out here, this is 12 and this is 5. Okay, now you won't necessarily have to do this work on every single problem, but you know, I like to do problems that are a little bit maybe more complicated than what you would see in your practice so that you're prepared. But if you set up Pythagorean theorem, 5 squared plus 12 squared equals x squared, with your hypotenuse being x, of course, you end up with 13. This is 13 inches. So the height of this triangle is 13 inches. So the area of these triangles, half of the base times the height, and there's 4 of them. So that gives you 260. So then if you add those two numbers together, 360 inches squared is your surface area. So now the lateral area, remember lateral means side, it's just the area of all the sides. This would be the 4 triangles. So that's just 260. So that's why I always find the surface area first and then the lateral area, because usually you don't have to do much work to figure that one out. Okay? Now the volume. So anytime you're finding the volume of a pyramid, it's going to be 1/3 of the area of the base times the height. And every time I'm teaching this in class, I always say, now if I was super creative or like kind of hands-on, I would show you how this works. Like I have like 3D shapes, like actual manipulatives, that I sometimes will get out and show kids. And the thing is, if I had, see if I can explain this in a way that makes sense. If I had a prism that instead of coming to a point, this was just a rectangular prism. If I filled up 3 of these, like with sand or water or something, and dumped it into that prism, it would equal one of those. So I guess that wasn't that complicated, but like it's just a third. The volume is a third of what fits into like a prism that doesn't come to a point, if that makes sense. Anyway, it would just be like I could just show you that that's true, but now I'm just telling you it's a third and you have to believe me. Okay, so anyway, so a third, the area of the base is that square, that's just 100. And then this is the height of the prism. So again, just be careful you're not using the height of the triangle. It's the height of the prism, which is 12. So this just comes to 400 inches cubed. Okay. So pyramids aren't too bad, right? Because you can just figure out what shapes make up the surface area, find their area, and then this is the formula for the volume. So just be careful, you know, distinguishing between the height of the sides and the height of the prism. Okay, let's do the cone. I know you're pumped. I can tell through the video. Alright, so let me give you your values here. See if I can make this straight so you're not, okay, you know what, let's just go like this, so I don't have to write crooked. Perfect. Okay, so let's say that's the center of my cone. It's clearly not the center of my cone, but whatever. Okay, so this is 9 centimeters. Dropped in the height. Drop it like it's hot. This is 12 centimeters. Okay. Alright, so for the cone, now we can't say, oh, this shape makes up the surface area. So we have a formula. It's the area of the base plus the side of this cone. We call it the area of the sector. That formula is just pi times radius times L. And I will tell you what L stands for right now. L represents the slant height. So you might think, what idiot chose L to represent the slant height? Because slant doesn't start with L. And then I would say to you, well, probably this so-called idiot didn't choose S because S's look like 5s. So they were actually being very smart. So it's just a cursive L, and that's the slant height. So this right here is the slant height. Okay? So the area of the base is a circle, so this is pi r squared, plus pi times radius times slant height. So now we can fill in what we got. So you just always want to pay attention. Were you given the radius or the diameter? You were given the radius, so pi times 9 squared plus pi times 9 times, oh my gosh, I don't have the slant height. Well, that's fine because this is a right triangle, of course. And of course, we're going to use Pythagorean theorem to find the slant height. Just got to do a little detective work. So you should end up with 15, right? This should be so easy to you in second nature by now. It's not even funny. So your answer, now I know I said this in my one example before, but if the question was asking you, or the problem was asking you to leave your answer in terms of pi, all you would do is just pick out the numbers, ignore pi. So 9 squared would be 81 pi, plus 9 times 15 is 135 pi. So and my answer in terms of pi would be 216 pi centimeters squared. Right, it's just like a nice answer. It just looks nice. When you put that in your calculator, then you get approximately 678.6 centimeters squared. Okay? This is your answer in terms of pi. That's just your answer. So then the lateral area, of course, would just be the surface area without the area of the base. So this is just pi times radius times the slant height. This number right here, boop, boop, just move that over. So I have that answer as 135 pi. And that decimal, one moment please. Oh, 424.1 centimeters squared. Okay, pretty easy formula. And now the volume is the same formula as the pyramid. So it's a third of the area of the base times the height. So third times pi times 9 squared times the height of the cone, which is 12. So if you left your answer in terms of pi, you'd have 324 pi, which is approximately equal to 1,017.9 centimeters cubed. That's it. So fun. I know you guys love it. Hopefully it made sense. Thanks for watching.